Welcome back to our channel. I'm Teacher Cedric, and today we are going to look at some geometry problems from the RI exam this year, the year 2023. Now let us start with the first question. We are given this shape. Can you find the area of the shaded region over here? Now this shape is something that we learned in our class. Let me remind you that whenever you see a lot of parallel lines, for example here, it is going to have something to do with the hourglass model and the similar triangle. For example, we see that GHIAC is an hourglass model. And it tells us that AC to GH, the ratio is the same as CI to IG. And since we do know that the length of AC is just 8, and GH is also 8, it means that CI and IG must also have the same length. Therefore, we can find that since AC equals GH, CI also equals IG, so that GI and IC both equals to 4 centimeters. Now, can you find a similar triangle in this shape? We could. For example, the triangle ACI is a similar triangle. And with similar triangle, we can see that AB to AC is the same as BJ to CI. So we can find that AB is 3, that is given, AC is 8, CI is 4, which is what we just found. We can easily find that BJ has the length of 1.5 centimeters. And that basically solves this problem. Now, from BJ equals 1.5 and the total length FB is 5, we find that FJ is just 3.5. And with CI equals 4, LC equals 5, LI or IL is just 1 centimeter. And from there, we can easily use the area of the trapezium to find that the final answer is 11.25. And that solves our first problem. Now, the main takeaway of this problem is that whenever you see a lot of parallel lines, for example, the line EA, FB, LC, HD, because they're all squares, it should remind you that I could use hourglass model or similar triangle. Let us move on to the next question. Given that area of the triangle ADE is 578, could you find the length of AF? Well, if you have no clue, attempting this question, let us first try to fill in some information that we do know. For example, since this angle is 90, this angle is 45, we know this angle must also be 45. And since this is 45, this is 90, then here must be 35. And then there we go, we have found another isosceles triangle ADE. And we do know that this area is 578. From that, we can easily find that the sides AD and DE, which are the same, is just 34 centimeters. Now, what is the next step? We're just one step away from finding the final answer. The length of AF is just 2 times this value, which is 68. Now, you might be wondering, why is that? Let me show you. Let me isolate this triangle ADF over here for you. I know AD is 34, and this is 90 degrees, 30 degrees, so this must be 60 degrees. And from here comes the magic. I can flip this triangle to the bottom. So this is 60 degrees, this is 60 degrees, this must also be 60 degrees. So that this triangle is an equilateral triangle. And we know that equilateral triangle all have the same length. All 3 sides share the same length. And if AD is 34, then this must also be 34. So as AF will simply be 2 times 34, which is 68. Now that solves our second problem. Now, it is worth remembering that whenever you have a right angle triangle like this, with one angle 30 degrees and the other 60 degrees, the hypotenuse is always double the length of the sides corresponding to the 30 degrees angle. Now let us move on to the final question of the day. We have this huge triangle ABC. And given that AD to DC is 2 to 1, and the area of AGE is 12.6 more than the area GDF, can you find the total area of this triangle ABC? Well, since I've given all the ratio of the base of this triangle, it is quite obvious that we are going to use the equal height model. Now, from the equal height model, we see that the area of ABE and AEF and AFC should all be the same because they have the same base, they have the same height. So let me denote all these areas as U, U, and U. They're all the same. Now, can you find any other model in this shape? Now, beside the ratio given on this side, I've also given the ratio on this side. Now, if I have two sides with non-ratios of the two sides, it immediately tells me that it is going to have something to do with the bird hat model. Now, from the bird hat model, we see that the triangle DFC has the area of 1/3 and another 1/3 of the total area of this triangle ABC, which can be expressed as 1/3 times 1/3 times 3U, which equals just 1/3 of U. So I know DFC is 1/3 of U. And now we're just, again, one step away from the final answer. We see that DFC is 1/3 of U, and here is another equal height model, so that DEF should also be 1/3 of U. And from there, we see that the area of the triangle AEF minus the area of the triangle DEF is just 12.6. Why is that? This is also what we learned in our class. It's called the principle of fixed difference. To make it more obvious, let me write out AEF as AEG plus GF, which is this area plus this area, minus DEF, which is simply DGF plus GEF. And we see that this GEF cancel each other. I'm only remained as AEG minus GDF, which equals 12.6. Now, I know that U minus 1/3 of U is 12.6, so I can easily find that U, or 3U, the total area of ABC, is just 56.7. Now, this is such a great problem. It involves three very important ideas that we introduced in our class. First, the equal height model. Second, the bird hat model. And third, the principle of fixed difference. Now, I hope you learned something from today's lesson. And if you find this useful, please subscribe to our channel, press the like button, and I'll see you soon. I'm Teacher Cedric. Bye.